This is the second video on the required practical investigating force equals mass times acceleration. This is the one where I'm going to show you what to do with your results. Now I'm hoping now your results table looks a bit like this with some results filled in. So you've got the mass that we've hung on the end and you've measured the time the trolley took to get through the light gate when those masses were accelerating it. Step one, you're going to fill in the force column. Now this is the force making it accelerate. The force is due to the masses that you put there. So what you're going to do is you're just going to find the weight of those masses. So for the first one I'm going to do 0.100 multiplied by 9.8. So my first one's going to be 0.98 newtons. Okay. Second one you'll do 0.2 multiplied by 9.8. Okay, and you are going to carry on 0.3 times 9.8 and so on and so on. You don't need to write the calculations in, you just need to write the answers. So if you've not done that, could you get that done now for me? Okay, hopefully you've got all those done and you can check against mine because this will be the same for everybody. The next bit, when I process my results, I will have slightly different results to you. Now, first thing you've got to do is, so step two, it's the average times. Now, for the first set of my results, and remember yours will be slightly different, finding the average, I've got to add the two together, and then I've got to divide by 2. So I'm going to add these two together and then divide by 2. So if I put that into my calculator, just got to be a little bit careful because sometimes people can make a slight mistake on this. So 0.15764 plus 0.15926. At this stage, press equals, or if you like, put that bit in brackets. But at this stage, I press equals, and then I'll put my divide by 2 there. Okay, and that gives me a result of 0.15845. Okay, you can just have a think about that. Does that result sound right? Because it should be in between the two different results that you've got, and it does sound right. So I'm going to fill in all of my averages. I'd like you to do the same now, please. Okay, the next column's the speed column, and this is the speed at which the trolley is going through the light gate. So we're going to use our key equation, one that you do need to know for speed, and that is just speed equals distance over time. Now, the distance it travels as it goes through the light gate is the length of your interrupt card. Okay, so that's how far it goes as the light gate, the beam gets broken. So you need to have your length of your interrupt card. Mine was 0.133 meters. Okay, and you're going to divide that by the time taken. Well, my first results, the time taken was 0.15845. I've just used my average result there. And so I'll put that into my calculator and I get a result of 0.83938 and so on and so on. Now, I only know this number to 3 significant figure. I can't measure some more precision than 1 millimetre without using some different equipment than a ruler. So I'm just going to record my speed to 3 significant figures as well. So I'm going to put this to 0.839. There's no point writing all of the other digits. So 0.8339 metres per second. So I'm going to pop that into my table of results, and then I'm going to work out for all of the others. It's always going to be the same distance, it's the length of the interrupt card, but I'm going to change this number and put in all of the other average times and work out my speeds. Could you do the same, please? Right, I've got all the different speeds sorted now, and you can see that it's looking good because my speeds are increasing as the force that's pulling the trolley also increases. So the next thing I've got to do is I've got to find the acceleration. And to do that, I'm using one of the equations on our equation sheet that you get in the exam. Okay, so this isn't one that you need to remember, it's one that you're given, but you need to know it exists. We're using final velocity squared, take away initial velocity squared equals 2 times acceleration times distance. Okay, so if we try looking at this with my first set of results, well, our final velocity that we're going to use is this number here. This is the speed it got up to, 0.839. So I've got 0.839 and it's squared. So 0.839 squared, take away. Okay, the initial velocity squared, well, we started with a velocity of 0. So I'm going to take away 0, or 0 squared, because that's still 0. That's going to be equal to 2 times the acceleration times the distance. So if I put that in my equation here, I've got 2 multiplied by the acceleration, well, that's what I want to find, multiplied by the distance. Now the distance travelled by the trolley you recorded at the start of the experiment. My trolley was travelling 0.632 metres. So I'll put that in to show you how to do that, 0.632. Okay, so now all we've got to do is rearrange this, okay? And if you're doing higher or physics, you will be expected to be able to do that in the exam. So 0.839 squared, take away 0, well, I can just leave that bit. Then I've got 2 times acceleration times 0.632. So if I multiply 0.632 by 2, I can just simplify that to be equals 1.264 times the acceleration. So if I want acceleration on its own, I need to divide both sides by 1.264. So I've got acceleration is equal to 0.839 squared divided by 1.264. If I put that into my calculator, 0.839 squared divided by 1.264, I get an acceleration of 0.55. I'm going to round it again to 3 significant figures. I've got this big long number. I'm just going to round it to 3 significant figures, and that's obviously in metres per second squared. Now, if you're going to be looking at doing this for all of your results, can you see after I rearranged it, it was just acceleration is equal to the speed it gets to, the final speed squared, divided by this distance. This distance always stays the same because that's the distance it went. So my next acceleration, I got my next final speed to be 1.1. So I just put in the same, I'll put in the same numbers apart from I'm changing that number to 1.1. So it's the same equation, 1.1 squared divided by 1.264. That will give me my next acceleration. So you're going to square your speed and divide it by your distance, and that should give you your acceleration. And you need to record your accelerations in your results table. Right, the next thing we're going to do is we're going to draw the graph. So if you remember at the start we said we're going to draw a force against acceleration graph, and we're hoping it's going to be a straight line. Okay, so get your graph paper and have a think about the scales you're going to use, because I've got force, which I was going to put on my y-axis, and my force goes from 0.98 to 5.88. So what I'm going to do for my force, I think I'll put my paper around this way, and I can have 0, 1, 2, 3, 4, 5, 6, and it fits in nicely like that on my y-axis. Now obviously you are going to be using a pencil and ruler, not a ball pen, and you're going to label this, and this is going to be your force, and we measured that in newtons. Now on our x-axis we're going to have acceleration. Acceleration I've got to get from 0.5 all the way up to 3.2. So I'm going to go up 0, 0.5, 1, 1.5, 2, 2.5, 3, 3.5. That should fit in. So we're plotting our force column there against our acceleration column there. Okay, now make sure you label this axis as acceleration in meters per second squared and have a go at plotting it. If you plot it correctly, it should end up being a straight line graph like this one here.